Hi, I'm Vijaya from Hexagon. In this short video, we will learn how to build a tank model using Tank 14 software. So this is the tank main window. So here in the home tab, we have different panels like file options panel, edit panel, then followed by title page, followed by input panel, where in this input panel, we have all the various tank design items like general tank data, row specifications, shell settlement specifications, venting requirements, and other items. And in the analyze panel, we can perform the error check and analyze the model, and also we can create a 3D PDF file from the output report. And in the units panel, by default software uses English unit. Also we have other units like bars, newtons, SI. And next in the tools tab, we have configuration settings. Using make unit, we can create a custom units. Then using material database editor, we can create a custom materials, and other options like performing multiple run using batch processor and exporting tank model to S3D model. In the help tab, we have help topics where user can refer user guide and quick start guide, and also user can access smart support community via this portal. User can raise a ticket and cases, and also users can check the web for tank updates, and also there is an email support, and also user can access what's new in this version of tank. And also we have news feed here. So via this news feed, we can get all the latest tank version information like version, year, build date, and also users can participate in live webinars and recorded webinars, and also they can find the training information in their regional areas. Okay, along with regional and online training classes. Okay, next we'll go to the tools, we'll go to the configuration. Here in the configurations, we'll keep most of the data as default. So we'll change the units file in database definition. We will change this to tank demo data file, which is an custom created metric unit file. We'll click OK. Then we'll start to build a tank model. So by default, software always starts with general tank data. So in this design code, we have multiple design codes. So we have API 650, API 653, API 620, and EN 14015 code. So now we will select EN 14015 for this job, and this EN code is newly introduced in this latest version of the tank software. And next we'll start with defining the design temperature. So we'll define this design temperature 60 degrees centigrade, design pressure 2.5 kilopascal, tank nominal diameter 20 meters, tank shell height 12 meters, design liquid level 12 meters, bottom plate thickness 6 mm, liquid specific gravity 1.0415. And next we'll move to wind velocity 45 meter per second, and the default shell course material. We'll click the database. So we can see here, since the design code selected is European design code, so the material database will be of EN material database. So we'll select the general carbon steel S355J2 and we'll search this one, and we can see here the S355J2 with the different thickness values. So we'll select the first one, that is max thick of 16 mm, and we'll select the material. Next, the number of shell courses, we'll define this one as 6, and insulation details will keep the default values. Plate length will define 5 meters, course offset 2 meters, then the rest will keep as default. Next, in the shell courses, we can see software automatically distributes the height basing on the total height and the number of shell courses. In case if any shell course have different height, we can manually override this value. Next, we'll define the thickness. For the first 3 shell courses, we'll define 8 mm, and next we'll define next 3 we'll define with 6 mm. So after defining the thickness, tank model is generated. So we can see the open tank model, and corrosion allowance will keep the default values, and the material selected is S355J2, and the design stress and idle test stress are automatically populated from by the software. And next, the wind details. So for European code, wind input is not required, so we will be not filling any that information. And for the anchor bolt and gusset details, so here we have two procedures. First one, like software, basing on the design information, software will perform the evaluation and will suggest whether anchor is required or not. Otherwise, we can fill the preliminary design data, and the tank will perform the evaluation and will suggest whether the defined anchor is sufficient or not. Okay, now we'll define the anchor bolt and chair input. So anchor bolt diameter 56 mm, and threads per unit length we give the default value. Number of anchor bolts 20. Bolt yield stress 335,000 kilopascal. Bolt eccentricity 100 mm. Anchor bolt corrosion allowance 0, and will enable this evaluate anchor chair assembly. So height of the gusset, we'll define this value as 160 mm, and gusset plate thickness 20 mm. Distance between gussets 60 mm. Width at the top of the gussets 320 mm. Width at the base of the gussets 250 mm. Top plate thickness 25. And next, the top plate circumferential width 180, and top plate radial width 180 mm. Corrosion allowance on chairs will give this value as 0. Next, the low bolt tensile stress of the plates, will define this as 207,019 kilopascal, and we'll select initial anchorage type as mechanical bolts. And the last one, the anchor bolts ultimate tensile strength, will define this value 630,000 kilopascal. So here, after feeding this information, we can see the anchor chair assembly here in the 3D model. And next, we will define the roof. So here we will define simple self-supported cone roof, and here the further information, angle between roof and horizontal 12 degrees, and the available net area at roof to shell junction, it is 8,300 square mm, and thickness of the roof plate 15 mm, and the remaining information will keep the default values. And in general roof data for the node design, percentage of weights supported by shell will keep 100%. And for the roof evaluations, as per NSCheck K, we'll select the first figure, that is K3A. Then next we'll define corroded thickness of shell plate 5 mm, corrosion thickness of angle leg 10 mm, width of top angle or bar 100 mm, and the last agreed safety coefficient 1.5. Okay, now the roof is ready here. Next, we'll define the seismic data specification for seismic evaluations as per NSCheck G. So we'll define this value, first the site amplification factor 1.5. Then next we'll define the lateral force coefficient 0.25. Okay, now the model is ready with the input and the design conditions. So now we'll see the drawing view. So this drawing view is previously introduced in PVLAT software. Now it is implemented in this latest version of TANK software. So this drawing view along with bill of material is furnished here. So bill of material contains the complete information of the tank. Okay, now we will run the analysis by clicking the running man here. So after clicking this, immediately software will ask us to save the file. So we will say this as demo 1. So this demo, we will now save it. Now software will start to run the analysis. Okay, the analysis run is done, and this is the software output window. You can see the report list. So here we have report name, table of contents, user input data, error checker, then followed by all the technical reports. So in this error checker, we'll get the information on the errors and warning messages. And the technical reports, we can see here the technical text is highlighted in is not highlighted, it is with black color. So this indicates there is no any errors. So in case if there is any error in the report, the text will be highlighted with red color. Okay, so here we can see the report consists with input information and evaluation as per NSTK, and also here there is an the output report, it references with the code section along with equation or computation for the user review. Okay, also we can export this output report to PDF file or Word document by simple single click. So we can do that here. So we'll click this generate PDF file and we can see the complete report which summarizes with all the technical reports. So we can see here the summary and the output report with the input information and all the further calculations. Okay, so this ends this session. I hope you found that useful. If you do have any further questions, please don't hesitate to reach out to Hexagon Solutions. Thank you.